Good afternoon, everyone, and thank you so much for joining us for our first READI Journal Club meeting. We'll meet each month on the third Tuesday at noon via Zoom for a discussion about at least one research equity, accessibility, diversity, and inclusion related journal article. Today's article is titled Evaluating and Modeling Neighborhood Diversity and Health Using Electronic Health Records. The conversation will be participant-driven. We're fortunate to have two authors from the paper, Drs. Perzynski and Neal Dawson, who will share perspectives from behind the scenes. Before we begin, we'd like to share a bit about the CTSC. The Clinical and Translational Science Collaborative of Northern Ohio is a collaborative among Case Western Reserve University and its affiliated hospital systems, the Cleveland Clinic, Metro Health, University Hospitals, and the Lewis Stokes Veterans Administration Medical Center, Northeast Ohio Medical University, and the University of Toledo. We aspire to be a catalyst for high-quality clinical and translational science and transformative research to positively impact the health of those in Northern Ohio and beyond. As we plan for the continued evolution of the CTSC, health equity takes center stage. A large body of evidence links social, economic, and environmental disadvantages to poor health outcomes, which are reflected in stark differences in life expectancy, infant mortality, and rates of chronic conditions like heart disease and cancer for residents of different communities throughout our 9-county region. In the 2023-2030 grant cycle, our CTSC is focusing particularly on including the community in the process of clinical and translational research to better address health disparities and achieve equity. So let's do some introductions around the room. Feel free to put your camera on if you'd like. I'm Jaleese Thomas. I'm the Assistant Director for Strategic DEI and Health Disparities at the CTSC. Dr. Dawson, would you like to go next?
Sure. Neal Dawson, Emeritus Professor of Medicine, longtime member of the Clinical Research Group at Metro, and a current member of the Population Quantitative Health Sciences Department at Case. Have a long history of clinical epidemiology, health services research, and am happy to try to contribute to this session to help us think about what the future of research might need to look like to improve our understanding of how the world works and how these various disparities occur and how we might influence them in a positive way.
Absolutely. Thank you. Dr. Perzynski?
Hi, everyone. I'm Perzynski. I am a professor of medicine and sociology at Metro Health and the Population Health Equity Research Institute. I teach a class on research methods in the School of Medicine. It's firing up in a couple of weeks here. And I'm super excited to join as many of these sessions as I can this fall. This paper was like the one thing that I just want to preview about it. This was a labor of love because I think there were 3 or more rounds of free submission. It was a really intense effort for our team. And it was one of these where we thought nobody's writing about this and we really just feel like someone needs to. So we sort of just took it on as a project that we thought we needed to do.
Excellent. Thank you. How about you, JC?
Sure. Good afternoon. I'm JC Sharp-Deering, and I currently work in research administration at Case Western Reserve University, where I'm the director of the Conflicts of Interest in Research Committee. I'm here mainly not in that role, but as a curious private citizen, and I hold a master's degree in medical anthropology and remain curious about ethics and health equity. So I was drawn to want to participate in the conversation. I'm excited for us to have a couple of authors here and hope that they can walk us through some of the concepts. I've had a chance to interact with the paper just once, and I definitely have some questions that might be helpful to everyone else on the call. Thank you.
Thank you for being here. And then let's see, Zena. or we could have Lynette.
Hi, everyone. My name is Lynette Jarrod. I'm a new assistant faculty member here, assistant professor in the Department of Bioethics. My background is in information science, and I've done my work most exclusively on disparities in hereditary cancers and uptake of genetic testing. And so I was really interested in this paper and the opportunity to participate in this journal club. So I'm looking forward to learning more and getting to meet you all, and happy, as you mentioned, to see this labor of love go out into the space for all of us to consume it.
Thank you, Lynette. And for our final participant, Jara.
Hi, it's Gara.
Oh, Gara.
My name is Gara. I'm the HR coordinator at the biochemistry department here at CASE. I'm fairly new, so I'm trying to get all my feelers out to see if I can learn more about disparities in health. We have a lot of cancer research on our side of the department, so just trying to learn more, and excited to hear from these two authors about it. So,
All right. Now that we're fairly acquainted, Dr. Perzynski and Dr. Dawson, would you like to kick things off for us? Not to put you on the spot or anything. And I can also pull the paper up too, if that's helpful, if you would like me to go to a certain place.
Yeah, I think, so maybe hope I'm not putting Neal on the spot too much, but I feel like the problem underlying the paper is one that he and I have probably spent somewhere between 200 and 400 hours talking about for the past 24 years or 23 years. So I think that I would ask Neal maybe to set the stage for us a little bit in terms of like framing the research methodology problem, because it's really a research methodology paper, right? Like we're talking about the science of how to do research on health equity and population health in the paper. But I think that the very narrow problem is something I think Neal does a pretty nice job of introducing in a lot of different settings. And so I'm going to ask you to do that first, Neal.
Sure. So I will just sort of walk through the paper, which I have here in front of me. But in terms of sort of setting the stage for our discussion, electronic health research, electronic health record research is challenging at best. There are a few clinical questions that can be reasonably addressed by information in the EHR, but to begin to understand bigger problems, we should probably begin to understand EHR data as a place to begin to understand associations and develop leads for perhaps more depth in various research settings. And one of the things that we'll get to in a minute is the issue of trying to move from where we currently are in terms of research methodology, which also needs to have some additions to research education efforts. And so both of those things are important in terms of trying to move from where we currently are to where we eventually need to be. One of the things that is, front and center, part and parcel of almost every educational effort in research, clinical research, and so forth, is our effort to find the independent effect of individual variables. And then for those individual variables, we do some sort of an adjustment. there are circumstances where that is important, but there are lots of circumstances in which it's simply insufficient. One of the background features that we need to keep in mind is that the phenomena that we are studying come from systems, and those systems are often complex systems and need to be addressed in an effort that in which we recognize that individual studies will give us some amount of information about what's going on in that system, but different perspectives or different times or different cohorts may lead to different sets of associations and different sets of causal pathways. So what we currently measure are things like proxies, things that are associated with the phenomena that we are trying to understand, but are not mechanistically related. In other words, they're not things that we can manipulate and change the outcome that we're interested in, but they are things that are related to that outcome. From a biological point of view, a lot of effort has been put into biomarkers. Again, it's important, but recent work in many areas, such as recent work in Alzheimer's, where biomarkers are being measured for treatment of Alzheimer's and medications used to change those biomarkers without any direct evidence that they change the outcomes that are important to us. So we need to begin to work toward mechanisms, and those mechanisms work on multiple levels. Some of those mechanisms are biological, some of them are social, some of those are economic, and there are some references in the paper to the importance of understanding those underlying mechanisms. And the thing that the set of concepts we really need to add to our research efforts have to do with understanding interdependent features. In other words, the circumstances in which independent variables, the contribution of them is important. I mean, they're there, but there are lots of circumstances where it's much more important to understand the interdependencies within a system, which some of which lead to various pathways and various feedback loops that are important. And feedback loops in general is something that we in medical science and to a degree social science have not taken, I think, sufficient advantage of in terms of understanding those. One of the first design considerations in the paper is cohort identification and extraction. And so, what are we interested in when we think about a given cohort? Sometimes that's age, sometimes that is, and certainly classically we think about this in terms of birth cohorts. And birth cohorts, the health patterns of various birth cohorts can be very different. You think about the folks, then there's less of those than every day than there used to be. The greatest generation, which goes from 1901 to 1924, then the boomers, which is 24 to 64, they led very different lives. The greatest generation lived through the Great Depression, were raised at a time where infectious disease was the biggest killer of individuals. Boomers and subsequent cohorts have lived in a world where we not only have antibiotics, but we have much more effective treatments for lots of things. But we also have exposures to lots of chemicals and air pollution and other things that were less of an issue, say, early in the 20th century. So those, in terms of identifying the cohorts, one needs to identify both the cohort itself. What are you interested in? Is it men? Is it women? Is it certain birth cohorts? And also the period effects that occur for that cohort. In other words, if we think about treating type 2 diabetes, What we had to offer when I was trained and through much of my career wasn't very much. Now we have hands full of medicines that can be used to help improve the outcomes of folks who have type 2 diabetes. Another recognition for these circumstances, now that I've brought up type 2 diabetes, is that we use singular labels for lots of things that in fact are heterogeneous. Right now, we know that there are at least 5 different types of type 2 diabetes. And we haven't even explored those in all the different folks that live on this planet. Most of the data come from European types and sometimes some folks from India and others, some Pima Indians and so forth. So it's not as if we haven't studied any of the heterogeneity, but there's much more heterogeneity out there than is obvious in our current set of research efforts. Geocoding is another piece of this that's in the paper that's important to try to understand patterns of phenomena. This one of the efforts that preceded this was the paper that looked at basically socioeconomic position related variables that came from the census that were basically used to try to understand whether or not folks who come from well-resourced neighborhoods, the outcomes associated with that, and the risk assessment of those folks, whether that's the same for folks who come from well-resourced neighborhoods, and is that the same for folks who came from less resourced neighborhoods? The classic view of cardiologic approach until about probably 5 years or so ago has been to use the Framingham data and the updated Framingham data, the pool cohort equation, as sort of the be-all and end-all to assess cardiovascular risk. And yet from the paper that was published earlier by many of the folks, Jarrod and Adam and many other folks, demonstrated that the pool cohort equation in terms of assessing risk worked quite well for the top half of the socioeconomic position distribution. But the further we got into portions of the sample that came from less resourced neighborhoods, the pool cohort equation estimation basically fell apart. Well, what is important about that from a general point of view? The general point of view is to say, not everybody has the same set of risks for the same outcome. So that we need to understand heterogeneity in ways that we simply have not done sufficiently in the past. There are also differences in terms of age groups. And the age group difference to some degree has to do with age, but it also has to do with cohorts and the experiences and phenomena that have these various different age cohorts have been exposed to, as I referred to briefly early on. The paper, which I won't go into in any detail at this point, basically looks at different types of assessment approaches and discusses the advantages and disadvantages of those. Unweighted analysis of the entire cohort, sampling and weighting, stratification. Stratification is important in terms of trying to understand heterogeneity and understanding the commonalities within groups in terms of how they are the sort of risk features that are important in those in different groups. And so rather than relying on an average relationship across groups that are different, one should stratify and take a look to see whether or not the relationships in terms of things that lead to better or worse outcomes are the same in those groups, and they can be qualitatively different or they can be quantitatively different. Understanding that is important. Another thing that's discussed in the paper, the mapping and statistical analyses issues, and one of the points that my discussion so far makes and should be understood is that right now we tend to look at risks or likelihoods at various levels. In other words, we think and talk about folks who have a high likelihood of achieving good health outcomes and those who have lower likelihood of achieving good health outcomes. But as mentioned earlier, there's also this issue of heterogeneity among disease types, type 2 diabetes being one of many. And also the issue that, say, we got a hint of in the cardiovascular risk paper, is the issue that things that are prominent combinations of risks or likelihoods of various outcomes in one group may not be identical to those risks in other groups, and we have called that risk structure. So we need to understand not only risk levels, that is the likelihood of better or worse outcomes, and also understand risk structure, which gets to the issues of mechanisms. And for this sort of discussion, we need to think about the various levels of risk and contributions to heterogeneity. Some of those are biological, some of those are social, some of those are economic, and to think about this in terms of the within person sort of view, in which we think about, say from a clinical point of view, we're thinking about what's the best approach for this person sitting in front of me that's come to see the medical enterprise today. Another is to think about, well, what are the issues that lead to various good or bad outcomes from a population point of view, and both of those are important in terms of trying to understand disparities, trying to understand sufficiently how the world actually works so that we can influence the systems that lead to better or worse outcomes. Jarrod, I think that's probably plenty from me. I'm going to turn it back to you.
Wow, thanks, Neal. That's really great. I want to dial back a little bit to one of these early conversations I remember having with Neal a really long time ago, and thinking about I can remember sitting in Neal's office in about 2001 or 2002. Just a couple years after Metro Health had turned on its electronic health record system, right? And saying so hold up, everything that we do for every person here is going to be recorded in the computer. Everything, their blood pressure, their medicine, their lab, where they live, who they are, whether they're married, whether they smoke, whether they drink alcohol. Every time they move, we're going to know their phone number. We're going to know all the diseases that they have. We're going to know all of that on everyone here. And the person putting that in is basically a doctor or a nurse. And so thinking about my excitement at that time was this is unbelievable, right? So what you're saying is in 20 years, we're going to have a data resource that has over 1 million people in it, and we're going to know everything about them. And all the data is put in by basically a doctor. like the cost of me doing that as a prospective research study beginning in the year 2000 would be like, somewhere around $25 billion, right? like that, like that's roughly the cost of me funding that research study is $25 billion, beginning in the year 2000 and drawing it forward to today. So like there's no funder on earth that would write me a check for $25 billion to do that research study. And I remember in this conversation, like Neal sort of throwing a wet blanket on all of it and saying like, yeah, but this data is terrible. Like they might be doctors. Like we don't know the reason why somebody is there for their appointment. We don't know what stuff they type in versus they don't type in. We don't know that some patients are from some neighborhoods and some are from others, and some come to Metro and some go to the Cleveland Clinic. And there are reasons for that and insurance patterns. And some people come in like 15 to 35 times a year to see the doctor, and other people come in only once every 8 years. And like, so how do we deal with all of that mess and still make use of this essentially $25 billion data resource to answer questions about the differences between populations? And so like, that is really like the motivating feature behind a lot of the work that our team has done, and especially behind this paper. And it's sort of like saying like, look, and this isn't like called out in the paper. We as a team, we talked about this a little bit. I sort of want to say like, look, if you're going to go and read or do one of these giant machine learning, artificial intelligence papers that has a data resource of 1 million or 5 million or 100 million people in it, and you just, sort of send the machine learning algorithms after the data, like sort of like a horse race, right? You just ring the bell, like everybody's got a year, and like here everybody takes the data and like, well, what are we not knowing about cardiovascular disease or medicines about cardiovascular disease? Our hunch in this paper is like that way of thinking about the problem and the method for looking at data is fundamentally broken and is likely to come up with maybe a few interesting points, but probably a bunch of wrong answers, and not like the mechanistic and fine-grained understandings. And I think Neal and I could talk for hours about the numbers of examples. One of my favorite ones, though, that's sort of hidden and not really talked about in this paper, it's another paper by our group, and it has to do with like even the geocoding that plays a starring role in this paper. Like the idea that we have somebody's address and all their addresses when they move, and that we can geocode them, we can know things from the census at very fine grain, like about the block that they live on for a very long time. Lots of, and actually an amazing number of things to be able to characterize where this person is from and what their life is like without asking them. So in our process of doing geocoding, one of the things we discovered, if we just took for Northeast Ohio and for Metro Health in particular, and we did a sort, it's like, yeah, imagine we have a table, right? So think of like, and in that table is a single column, and that column is address, and the rows are all the addresses in the data of 4 million people, right? So you have 4 million people's addresses that they had over 20 years. And if we sort that column by the frequency distribution, so we just sort it by like the address that appeared the biggest number of times in the data, right? Like which address in Northeast Ohio appeared the most number of times out of those, out of all the possible addresses you could have in the electronic health record. There was one address that was far and away like appeared 10 times more than any other address in the electronic health record. Any guesses? Like, this is a great, like, sort of interactive question. Any guesses, like, what address would have appeared? Like, thinking about what you know, like, or what type of place, or like any guesses?
Long-term care nursing home facility.
Oh, that's interesting, right? So like, yeah, there's like maybe 100 beds, like people only stay for 12 to 48 months on average. Yeah, that's a pretty good, okay, good. Like Reasonably good guess, not the right answer. Other guesses. Some people have guessed like Reserve Square, like this like huge apartment building downtown that like has a lot of turnover. Like Cavs players live there. I think Terry Francona lives there. But like also I have students who live there. Like they have like a big, like big range of rents and types of apartments and centrally located. Lots, hundreds and hundreds of apartments. Like maybe so some people guess Reserve Square. That it's not that either. The address actually is 2100 Lakeside is the actual address. Like those of you who are more or less familiar with Cleveland, some people instantly know what that is. 2100 Lakeside is one of the longest running and busiest men's homeless shelters in the United States of America. It's at 2100 Lakeside. When you walk up to it, it's in sort of a weird, it's like this sort of like industrial location. And on Lakeside, you have actually like next to the building, you have this beautiful view of Lake Erie. If you do a Google Street View of 2100 Lakeside, the Google car that did Street View driving by just happened to be driving by in the afternoon around 4 or 5 p.m. when the shelter opens. And there's a line of about 50 or 80 men on the sidewalk before the door opens, waiting to get in to have a place to sleep at night. And so as it turns out, the most commonly recorded address in the Northeast Ohio electronic health record is 2100 Lakeside. This is a shocking piece of information, right? Also, like, this is not like, so when we geocode somebody to where they live and they live at 2100 Lakeside, there's actually nothing around there else, right? Like it used to be like, there's a bunch of like empty trucking and distribution warehouses that we used to use to move produce around the city of Cleveland, but we don't anymore. There's like a police training center over there. There's not much going on. Census data, as it turns out, is not super informative. The Berg Lakefront Airport is in the same tract as 2100 Lakeside. It's like not a helpful address for geocoding or census information. But knowing that it was 2100 Lakeside was really, really informative for us. So what we were also able to do was identify all of the other addresses in Northeast Ohio that were homeless shelters based upon address. And we also looked in the address field of the EHR and saw all the times that somebody just wrote down homeless or unhoused or no address or couch surfing. And so we were able to use the address field of the EHR to characterize the life of all of these people in there in a way that like we don't generally think about in data. And then we were able to do, like, I think one of the things that Neal mentioned is stratified analyses. So we wrote a paper that was a stratified analysis, just looking at the folks whose address identified them as at some point in their life as unhoused, versus those who had not been, versus those who lived in sort of high or low socioeconomic position neighborhoods, and comparing the distribution of sort of 20 or 30 common diseases among those groups, and finding a wildly different profile of disease among persons who are homeless, as opposed to among other persons, in what is now actually the largest ever published cohort data on homeless persons, right? Simply from data that we didn't even know was there when we were first looking in the EHR. And so I think the and our assumptions about what the first, the most common address would be, or what the data could be used for in the electronic health record are really sort of blown apart by that example and by some of the other like illustrations and figures in the paper, and about like what we learn if we use only Cleveland Clinic's or only Metro Health's data, right? Like if you look at the only Metro Health figure, it looks like there are all of these Hispanic and Latino, like we have this huge Hispanic and Latino population. But if we look at Cleveland Clinic, they have very few of those folks. Those folks just tend to come to Metro because they tend to live on the near west side. And a lot of them are immigrants, and maybe their insurance status drives, pulls them toward Metro a little bit more than to the Cleveland Clinic. So we're able to say a lot. But on the other hand, like There are other populations that we're going to learn a lot more about in the Cleveland Clinic data. So the strategy of combining data across systems tends to be really, really, really valuable. Like because if we just use data from one of our care systems, we're going to have a very distorted view of what the world looks like. And that can be distorted in any number of ways. So it's not to say that one system has the right view or the wrong view. It's really to say that like the view is distorted based upon how those people come to use healthcare at that particular institution. And I think, you know, one of my takeaways from that paper is really, and Neal brought this, like the idea that we can look at subpopulations and stratified analyses is not just exciting, but it almost feels like a necessity. And it feels like we need to do that whenever possible, not just across things like whether somebody is housed or unhoused, or male or female, or what their racial or ethnic background is, but also what their age cohort is. Another of my favorite analyses is we looked at just all the people in the electronic health record at the two places who are over the age of 85, right? Oh my goodness, there's almost 200,000 people who are 85 years and older in there. And we never look at them, right? They're the fastest growing component of our society, but and as it turns out, all that same stuff that Neal said about cardiovascular risk estimation looking differently among persons from low socioeconomic positions is even worse among persons who are 85 and older. Effectively, like our predictions for who dies of heart attack and stroke when we look at those 85 and up folks is no better than chance. Like what the equations that we normally use are no better than chance at figuring out who has a heart attack or a stroke when they're over 85. And yet we have this massive data resource, but we tend to ignore that those folks are in there. Or if you think about your typical clinical research protocol that might go through, like I would say out of the 250 protocols that are submitted to the Metro Health IRB every year, probably 95 or 98% of them exclude persons over the age of 80 or 85. We just like pretend that they don't exist and that their lives and their risks and things happening are unimportant. So it's no wonder that our equations and our predictions and our algorithms for what is going to happen to them fail miserably when we actually look in that data and test assumptions in those groups. And so the same thing, so I think when we're thinking about equity and disparities in these subpopulations, we have like what I would describe as a very, very nuanced view of this. And thinking of the multiple disadvantaged statuses that people have, race and ethnicity plays a starring role. So then what if we divide it further and we say like, well, what about persons who are 85 and older who are homeless? Or what about persons who are 85 and older who are Hispanic or Latino? Do our models work just as good for those folks as they do for other folks? Or what about folks who are Black men who have made it to 85, right? Because there are still like another 35 or 45,000 persons in our region's electronic health record data and every region's who are, Black men who've made it to the age 85. Yeah, like a lot of things have happened that have made it unlikely that those Black men might get there due to various disadvantages and disparities. But that doesn't mean that we shouldn't be concerned about the circumstances of Black men when they are over 80 or 85. What is the profile of their health conditions, risks, and outcomes? And so I think like this idea of doing stratified analyses and comparative analyses across strata is critically important. And I think like if there was one takeaway, like especially with this explosion of machine learning and AI algorithmic expertise and looking at, especially like as Neal mentioned about like biomarkers across groups, like, well, did we test the biomarker across like 10 or 15 or 30 different subpopulation strata to see if it's relevant or if it exists? Because when we have data resources that have 1 or 4 or 150 million people in them, then we have that capability, but oftentimes it's sort of like underutilized or I think our goal with this paper is like, let's give folks like a set of very simple tools and simple strategies that would allow the scientific community to have an easier access point to conducting research on equity challenges and and problems that without screwing it up as badly as it typically gets messed up. Because this is the other problem, is like the just like massive frustration at a lot of the work that is published that doesn't use really any of these techniques. Okay, so I have talked long enough too, and I think hopefully folks have a few questions.
Lynette, would you like to come off mute, or would you like us to ask your question that's in the chat?
Sure. So thanks again for this work. Something that I've found very challenging to talk about with folks. And I think you all have done an amazing job of trying to break down like why we need to sometimes hone in and stratify within groups and look at and compare groups within that on other levels to make a more nuanced view. So you mentioned this kind of race to, I think maybe it's because it's a laborious task, what you all have worked towards. And so a lot of times people are trying to cut through it fast, and they're like, okay, like you said, let's send a large language model out there and let's just see what we can find, as you mentioned. And that seems to be what is kind of exciting and shiny. But sometimes this type of work is not as sexy, for the lack of a better word, and it's not necessarily getting the funding or support that it needs. What would be your suggestions, considering you've been working on this for such a time, and for younger or more junior researchers just getting started building our portfolios with these types of approaches?
Oh, thank you for a fabulous question. So I'm sure Neal has answers. There are two things that come instantly to mind. The first is like one of my favorite types of research projects and papers to work on was described by my former mentor, Carrie Cart, as like the debunking paper, scientific paper. And like, honestly, like a few things are more rewarding than writing a paper that says that so many other people are wrong. And it's also a great way to like get invited to talk about stuff. And also it's a great way to open an insightful scientific dialogue. So I think one of the things that our work in this area has done is provided some opportunity and a pathway for doing a somewhat, like if literally all you have to do to debunk a bunch of other work is to do a stratified analysis, like across like, and like that is a great thing to do, and it's fun to write and it's fun to work on, and there's generally not a ton of risk. And then so then the other, like this has happened twice with two of these types of papers that we've it happened once with the cardiovascular risk paper in 2017, and there's actually like a published commentary and then our response to that commentary. And then it also happened with a lung cancer paper, I think in around 2020, 2021, with and in that paper, I think it was an editor and a reviewer they both made the exact same comment, but in different contexts. And the comment was, well, so some version of like, well, so you're looking at persons who live in low socioeconomic position neighborhoods, and you're saying that these models aren't adequately accounting for their risk, and that neighborhood or socioeconomic conditions in neighborhoods seem to account for risk that's not accounted for by the risk model. And so that could be the Framingham model that includes like blood pressure, smoking, lipids, age, sex, diabetes, right? Or it could be some lung cancer risk model that includes, you know, basically all that same stuff, some, you know, maybe some nuanced view of smoking. And so and we're thinking like, wow, what are they going? And then for the cardiovascular risk commentary, the comment was like, but couldn't there just be like something else? Like, don't like people who don't have money, they just don't do healthy things, or they have more exposure to unhealthy things. And it's like, and they gave some example in that one, which was like passive smoking. So they said, like, isn't it just that like poor people have more passive smoking, and you don't have passive smoking in your data? So like clearly like the Framingham model is probably fine, and you just like don't have passive smoking. So then what we did was like, well, we had, okay, smart guy. What if we did a stratified analysis in our model that we originally published in the paper? And we said, like, what if we just looked at all the ever smokers? Like, how about this? We'll just replicate our entire study because we have 1 million people. Like, we'll just look at the 140,000 people who smoked for at least 10 years. So we did that, and we found that our findings were exactly the same in the ever smokers. Like, no, it's not. It's clearly not just smoking. So like, sometimes there's this impetus to say like, oh, it's just this thing that's associated with some prejudice and pre-existing bias or something that we attribute to some subpopulation without actually testing it. But the exciting thing about this kind of data, and I think this is sort of a roundabout way of getting there, it's like, well, why don't we just test? So interestingly, in the lung cancer paper, we had almost the exact same comment from a reviewer, which was like, so that paper was only in ever smokers, and it was about risk of lung cancer as attributed to neighborhood. And they said like, yeah, but like, isn't it possible that like people in these low socioeconomic positions, neighborhoods, like it's just about like, maybe they smoke more intensely. Like they like so they're ever smokers, but like maybe they have like more pack years, or like when they're smoking, like they just like it's worse than somehow. We're like, okay, like that might be it. So then what we did was we did the same thing. We just stratified, and we looked at the people who had like 80 pack years or more, like just like so much smoking, right? And what we found was that the inverse of what the reviewer had postulated was true. Like actually in the 80 pack year for folks, like the effect of neighborhood was even more intense. So that the odds ratio went of a bad outcome actually went up. So I think sometimes the thing here with this, particularly with electronic health record data, but across anything, it's like in this world of huge data resources, is that the huge data resources, in fact, are your friend. Like there are like, don't hesitate to take the question right back to the data, because yeah, maybe the reviewer is right. Maybe that skeptical person is right. Like we have tons of data. We can look at the stratified sample and answer the question. We can do the sensitivity analysis. Why not? Because we didn't have to spend $25 billion in 20 years enrolling the participants. Instead, we can invest a lot of our time in great biostatistics teams and epidemiology, and every now and then we'll throw a sociologist on the team and really ask questions in a way that maybe are a little bit unconventional, but super effective. Yeah, I think hopefully that's a somewhat roundabout but also a helpful answer. I suspect Neal has other things to say.
Well, I was thinking while you were talking about risk structure for these groups. So one of the things that we've not paid much attention to, maybe until the last 3 or 4 years, is air pollution. And poor neighborhoods are systematically more exposed to air pollution, especially the small particulate matter. And they can contribute to lung cancer, they can contribute to lung disease, they can contribute to cardiovascular illness. So that so the contribution of that to the population level risks can be systematically different, say from poor neighborhoods in Cleveland to Solon, or places that are out in the country that really are not exposed to much of the small particulate matter in today's world. Comes from traffic, it comes from exhaust, it comes from rubber that comes off tires. And the exposure of those sorts of things to folks who live out in the country someplace is very different than those who live right next to some major thoroughfare. And so anyway, that's a small point. Another sort of, I think, more general issue in terms of looking at these sorts of things and trying to think about issues of getting funded and trying to look at these bigger problems, is the issue of longitudinal data versus cross-sectional data. Because it's easy and quick, we use cross-sectional data all the time. And I don't have any difficulties with that. What I have a difficulty with is that we use it. We talk about all the advantages and the positive associations and so forth, and what gets short shrift is really the limitations and how we need to understand the limitations of the cross-sectional data and how that might be changed by longitudinal data. And an extension beyond that is something that you and Jarrod have taken on, and that is the use of simulations, so that you basically create data based on how you think the world works, and then you test hypotheses. You say, okay, if the world works this way, we would expect the answer to this particular question to turn out this way. And in many respects, and this is backing off to a much bigger picture, the enterprise of weather forecasting is something that we can take we can adopt various things that they have done for decades. And one of the things that they do, first of all, the data that they use are mechanistically related to weather aspects. The second thing they do is they don't accept a single answer from a model. They create dozens of models. And they have, in worldwide, there are two sets of models. There's European model and the US GFS model, and so the comparison is made between those multiple models, and sort of what is the center of these various models, and what is the variation among these models, all based on mechanistic relationships, and so trying to come up with the answer to a question from a single study, from something that originates from a system, especially if that system is a complex system, is something that we just shouldn't do anymore. We should accept it as an important piece of information, but it's not the answer. The answer doesn't come in single packets about a single variable. It's independent effect, but that is sort of our current status. In terms of funding, as Jarrod, as Adam has mentioned, the putting out certain papers can in fact influence the thinking of funding entities. And there are several papers that have led to the issue of funders beginning to think about and give funding to disparities work. And that can be pushed further into the direction that we think will be helpful in terms of trying to understand these interdependencies and feedback loops and the things that and the mechanisms that make the world work, and then figuring out okay, and the fact that it's just like with weather forecasting for a microclimate is not the same as forecasting for, say, the rest of the state. If you think about California in the summertime, in the south of San Francisco, you have nice, warm, sunny days. And San Francisco, according to Mark Twain, he said, my summer in San Francisco was colder than any winter I've ever spent elsewhere. Something to that effect. The coldest winter I've ever spent is the summer in San Francisco, is basically what he said. Anyway, why is that? That's because you've got this huge opening in the coastal mountains, and you have fog that rolls in, and it's cold. And then you have the mountains that basically stop the fog south of San Francisco. So you can't come up with the same model for two places that are 30 miles apart. And the weather forecasters recognize that. We don't. We have, there's some parts of science that, certainly in terms of moving things along, it's been appropriate for them to basically look at nomothetic relationships, which are lawful relationships. What's the law what is the natural law that makes this phenomenon occur? But even in the traditional areas, such as physics, it's not like that anymore. It's context matters, how the world works, and the interrelationships of various particles and subparticles and gravity and so forth. are different depending on which part of the universe you're in and what you're talking about. So that certainly understanding general relationships when they in fact exist is very important, but it's no place to stop. We've got to understand how circumstances and contexts vary across various levels, whether they're biological or social or economic, and the influences those have on individuals who are members of various subgroups. And we need to be more thoughtful about what those subgroups are, and as Adam is suggesting, how we study them.
Thank you. And did anyone have a final question? I know we're at time, but just wanted to provide that opportunity. Okay. Well, thank you so much, Dr. Perzynski, Dr. Dawson, for your insights, for your very hard work and labor of love, and may we all embody your spirit as we pursue health equity and health disparities research and work. And we hope that you'll join us next month. Have a great afternoon, everyone.
Thank you.
Thanks, everyone.